Unit number second, instrumental methods of analysis. In this unit, study of the instruments like conductometry, pHmetry, and electrodes. See first introductory part of this unit. What do you mean by the cell first? Cell means a cell consists of two electrodes in contact of an aqueous medium. The electrodes like anode and cathode. First, what do you mean by the anode? Anode is the cell is electrode at which oxidation occurs. Cathode means is the cell is electrode at which reduction occurs. First, what do you mean by the oxidation and reduction? Oxidation means loss of electron and reduction means gain of electron. General cell representation of the any reaction is first is anode, direct contact with ions denoted by the single line, then indirect contact of ions of cathode and direct contact of cathode. That is the example of the Daniell cell. Daniell cell is the example of the unit number second, instrumental methods of analysis. In this unit, study of conductometry, pHmetry. First, see the introductory part of this unit is first, what do you mean by the cell? A cell consists of two electrodes, that is anode and cathode, is in contact of an aqueous medium, that is cell. Anode is the cell is electrode at which oxidation occurs. What do you mean by oxidation? Oxidation means loss of electron. Next is the cathode. Cathode is the cell is electrode at which reduction occurs. Reduction means gain of electrons. The general cell representation is, see the anode, direct contact with ions denoted by the single line, that is a direct contact, then indirect contact with the ions of cathode denoted by the double line, and single line is denoted as a direct contact with cathode, that is anode, ions, direct contact with ions of cathode and cathode. Example is Daniell cell. See, copper, direct contact with copper ions that is a oxidation occurs in direct contact with zinc ions and direct contact with zinc. This is a simple general representation of the Daniell cell. Next point, reference electrode. First, what do you mean by the reference electrode? Reference electrode is defined as the electrode which has stable and reproducible potential and complete the cell, acting as a half cell and to complete the cell is called as reference electrode. There are two types of reference electrode, primary reference electrode and secondary reference electrode. The primary reference electrode, the example is standard hydrogen electrode whose potential is 0 volt. Standard hydrogen electrode, the potential is 0 volt. Second one is a secondary reference electrode. See, the example is a main example is the calomel electrode. See the calomel electrode. This is most widely used reference electrode. See, the diagram of the calomel electrode is, it consists of narrow glass tube. At the bottom of the, it consists of narrow glass tube. At the bottom of glass tube having liquid mercury. Above it is paste of mercurous chloride, and remaining portion of glass tube is filled with 0.1 normal or 1 normal or saturated KCl solutions. KCl solution. A platinum wire deep into the mercury layer is used to make electric contact. It is a simple use of platinum wire. A dipping of type of calomel electrode has tapering lower end and the bottom is porous. In the some calomel electrodes there is side tube filled with gel for acting as a salt bridge and make the electric contact. See the general reactions of calomel electrodes. If calomel electrode act as anode, that is oxidation reaction takes place, that is a 2Hg plus 2Cl, that is a chloride ions, reversible reaction with Hg2Cl2 plus 2 electron, that is a oxidation reaction. If calomel electrode act as a cathode, reduction reaction takes place, that is Hg2Cl2 plus 2 electrons reversibly 2Hg plus 2Cl minus. Representation of this electrode is given by the, that is platinum wire direct contact with mercury with a single line, direct contact with Hg2Cl2 paste and direct contact with the chloride ion, that is a KCl. Simple cell representation of the calomel electrode. Next point, potential determination of calomel electrode. reduction electrode potential is calomel E calomel, that is the potential of calomel electrode, is equal to E standard minus 0.591 log of base 10 of concentration of chloride ions. See, the E standard, this value depends on the concentration of KCl solution. That is, E standard value, if the concentration of KCl solution is 0.1 normal, then the E standard value is 0.3334 holds. If 1 normal, 0.281 holds, and saturated in this time 0.2422 holds. This is that is the E standard value depends on concentration of the KCl solution. Next, demerits of calomel electrode. First, it should not be used above 50 degrees Celsius because of Hg2Cl to start decomposing. Second one is it involves handling of poisonous mercury and Hg2Cl2 paste.